Okay, so this first problem, you may have noticed that you have intersecting lines, of course, but within that you have vertical angles. So this angle and this angle are vertical angles, so therefore they have the same measure. And then you can set those equal to each other to solve for y. So that's where I would start. Also, just looking at this before we get into the solving, you have a linear pair right here, and these two angles are supplementary. So you could say this plus this equals 180 to solve for x. But starting with the vertical angles, y plus 23 equals 63. Then you would have subtracted 23 from both sides and gotten y equals 40. Is that what you got? Yay, good job. And then we also need to solve for x. Like I mentioned, we have a linear pair here. That means that those two angles add to 180. Did anybody solve it a different way than that? Because there are other ways. Kirsten, how did you do it?
So I did 180 minus 63 to get the...
This angle here?
Yeah, and I got 117.
And then you could set it equal.
Yeah, I set equal.
Awesome. Yeah, the answer is x equals 67. So if you did it a slightly different way than I'm showing you, and you got 67, great, because there is more than one way to solve this. But like I said, one way to do it is this plus this equals 180. So 2x minus 17 plus 63 equals 180. Minus negative 17 plus 63 equals 46. So plus 46 equals 180. Subtract 46 from both sides. 2x equals 134. And then x equals 67. And there's your answer. Okay, next, while we're in this area, I'm going to go through these problems here. These problems do incorporate some of the concepts we're going to go over today, but a lot of them we've seen before. So honestly, based on what you've already learned, you could solve these. So here it says our given is angle 2 and 3 are complementary. So 2 and 3 right here, this is 2, and this is 3 are complementary. So this right here equals 90 degrees, those two added together. Then it also says that angle 1 and angle 4 are equal, or congruent. So this angle is the same measure as this one. And last but not least, it tells us measure of angle 2 is 28. And we're going to find the measure of these other angles. Something to realize is that these 4 angles come together to form a straight line, so therefore these 4 angles will add to 180. And even though that's not stated in the given, based on the picture, that is what's happening. So first of all, I'm going to find angle 3. I know this is 28, and I know these two are complementary, so to find angle 3, I can do 90 minus 28, and that comes out to 62. So angle 3 is 62. Next, I need to find angle 1 and angle 4. They're both equal to each other. I know that this whole thing adds to 180 and this part adds to 90. So if I do 180 minus 90, I'm left with 90 degrees. That needs to be split evenly among these two angles. So 90 divided by 2 equals 45 degrees. So each of these is 45 degrees. Okay, and the next one. These are kind of like puzzles. Some of you may love it, some of you may hate it, I don't know. Number 3, it gives us this drawing here. It says 2 and 4 and 4 and 5 are supplementary. So it's saying angle 2 right here and 4 are supplementary, meaning that they add to 180 degrees. Then it also says that 4 and 5 are supplementary, which we can see because they do come together to form that straight line. So because it's a linear pair, they are supplementary. And then it also says that angle 4 is 105 degrees. We're doing a lot of labeling here. A lot of your testing, actually all of your testing in geometry, your standardized testing that is, will be on a computer. With these proofs, a lot of times you're gonna have to like sketch this out on a piece of paper so you can label it and like see it as a picture instead of just words, just FYI. Okay, so now that we have everything labeled, we're gonna find the value of all these other angles. Here, this is a linear pair. It also said it's supplementary, so 180 minus 105 will give us this measure here, which would be 75 degrees. Then part of the given was that angle 2 and angle 4 are supplementary. So if this is 105, then 180 minus 105 is 75 degrees as well. And last but not least, we need to find the measure of angle 3. This forms a linear pair here. So that means these two are add to 180, so this has to be 105. And that's it. Oh, sorry. Okay, now we're going to go to the beginning of the lesson and look at the theorems and postulates for the lesson. Okay, so moving over here, angle proofs. First theorem for today. So yesterday we worked on segments, improving segments. Now we're going to work on angles. A lot of these ideas we've already seen, like complementary and supplementary angles. Now it's putting them in proofs. So it's review just maybe in a little bit of a different format. But first of all, we have protractor postulate. All protractor postulate is that you can measure an angle using a protractor. So to measure an angle using a protractor, you would line up one of the rays, put the vertex in the middle, and then use the protractor to measure the other part. The next postulate, and again, these numbers don't matter. It really has to go with more the book than it is the actual postulate. Angle addition postulate. Yesterday we learned that in a segment, this part of the segment plus this part of the segment equals the entire length of the segment. Angle addition postulate is the same idea. It says that this part of the angle plus this part of the angle equals the whole thing. The way we write this, or the way you'll see this written, is measure of angle, in this case ABD, plus measure of angle DBC is equal to the measure of the entire thing, angle ABC. Remember, when you name angles, you have to do it in order, and the middle letter is always the vertex of that angle. Okay, now the theorems for today. These will sound familiar. We have vertical angles theorem. If two angles are vertical, then they are congruent. This is like, if there was a most popular award for theorems, this is it. This is the one you will see over and over again. Vertical angle theorem. What this looks like is you would have two intersecting lines, and opposite angles are congruent. So 1 and 2 would be equal. Angle 1, measure of angle 1 equals measure of angle 2. And remember, vertical angles can be like this too. This would also be equal to this side over here. Complement theorem. If two angles form a right angle, then they are complementary. So if you have two angles that come together to form a right angle, then they add to 90 degrees. So angle 1 plus angle 2 equals 90 degrees. Supplement theorem. Supplement theorem, as you may guess, if two angles form a linear pair, so that means they form a straight line, those angles are supplementary. So angle 1 plus angle 2 equals 180 degrees. Next, this is the one that is new. Congruent complements theorem. If two angles are complementary to the same angle or to congruent angles, then they are congruent. what does this mean? Here you see three angles. If angle 4 and angle 5 are complementary, I'm just abbreviating that, and angle 5 and angle 6 are complementary, then angle 4 actually equals angle 6. And I'll show you why. Okay, so let's say that angle 5 is 60 degrees. And then we're told that 4 and 5 are complementary, so then angle 4 would have to be 30 degrees because it would have to add up to 90. Then you're told that 5 and 6 are complementary. Well, if they're complementary, angle 6 has to be 30 degrees because it would have to add to 90. That means angle 4 and 6 are equal. And the next one, congruent supplement theorem. This also works with supplementary angles. So if angle 1 plus angle 2 equals 180, and angle 2 plus angle 3 equals 180, then angle 1 must equal angle 3. And again, why does this work? If this was 150 degrees, if these two angles were supplementary, then this would be 30 degrees. And if these two angles were supplementary, this would be 30 degrees. Therefore, angle 1 and angle 3 are equal. Okay, thank you. Next, moving on to the next page. Right angle theorems. These are very much common sense, but they do come up in proofs once in a while. Theorem 2-9, perpendicular lines intersect to form 4 right angles. No dir. Perpendicular lines are lines that look like this. They form that right angle, but they actually form 4 right angles. So if this is 90 degrees, then because of the supplement or linear pair, this would also be 90 degrees. Vertical angles are congruent. This is 90 degrees, and vertical angles congruent 90 degrees. So perpendicular lines intersect to form 4 right angles. Then next one, all right angles are congruent. No duh. Right angles are 90 degrees, so therefore all right angles are congruent. Perpendicular lines form congruent adjacent angles. So here we have perpendicular lines. All these angles are congruent. Adjacent means right next to, and yes, they are all sharing a side. They're right next to each other. 2-12. If two angles are congruent and supplementary, then each is a right angle. So if two angles, so let's say I have this angle and this angle. If they are congruent, meaning they have the same measure, and they are supplementary, meaning they add to 180, then each is a right angle. Yes, they would both have to be 90 degrees. And then the next theorem, if two congruent angles form a linear pair looks like this. Oh, wait. Linear pair does look like that, but it's saying specifically two congruent angles are a linear pair. So they would have to have the same measure, and that means that they would both be 90 degrees. Okay, thank you. Next. Something that is just a small little note down here, the reflexive, symmetric, and transitive properties also apply to congruent angles. So remember, reflexive was, and I'll apply this to angles, angle A equals angle A. Symmetric would be like angle A is equal to angle B, and angle B is equal to angle A. And then transitive would be like angle A is equal to angle B, angle B is equal to angle C, therefore angle A is equal to angle C. Okay, next. We already did these, so we're good with that. Now we're going to look at different situations and decide which theorem or postulate, based on the ones that we went over on the other page and up here, apply to these situations. So first off, we have two intersecting lines. It's saying that angle 1 is congruent to angle 2. Remember, that is the most popular word, vertical angle theorem. Number 5. Looking at this drawing, we have a given, and we're going to look at why that conclusion is true. So angle 1 and angle 2 are complementary. So that means that they form a 90-degree angle. 2 and 3 are also complementary, meaning they form a 90-degree angle. And it's saying angle 1 is equal to angle 3. That is that congruent complement theorem. Number 6, given angle 1 and 2 are right angles, conclusion, angle 1 is congruent to angle 2. That was a theorem, all right angles are congruent.
Should we just put the number theorem 2-10?
I don't want you to, because those numbers don't have any meaning.
Okay, so
Yeah,
just
all right angles are congruent, yeah.
Okay.
Seven, angle 1 and 2 are supplementary. We can see that. Angle 2 and 3 are supplementary. And therefore, 1 and 3 are equal. That is that congruent supplement theorem.
I feel like these theorems are easier, or proofs are easier than the ones of yesterday.
Yesterday was you guys did good though. I know it took more thinking than normal. Normal is just like, you guys are math brains, so you normally don't have to think so much. I don't know, I guess let's find out if the proofs are easy or not. Then here we have angle 1 is congruent to angle 2. We see that. Angle 1 and 2 are supplementary, and the conclusion is 1 and 2 are right angles. That one is if you have two angles are congruent and supplementary. If two angles are congruent and supplementary, then each is a right angle. So I'm going to abbreviate this as much as I can. If two angles are congruent and supplementary, then you have two right angles. Okay, next. Yes, Olive. Which one? This? Ooh, ooh, ooh. Oh, this right here? Okay, next. You got it, Olive? 3, 2, 1. You can get it after. If somebody's ever missing a part, like, you can just get it after. So here we have complete each proof. We're going to look at 3 proofs together, and then I'll let you practice on the computer. Let's see. Yay. Come on, focus. Complete each proof. Okay, so just like yesterday, honestly, before I even look at this, I'm trying to get as many of these blanks correct, especially if something's partial credit. First of all, I'm going to make sure to put given right here. I don't even have to look at nothing. I just know that's given. And then the proof statement is going to be the last statement, so I'm definitely going to plug that in as well, because now I already got 2 out of them correct. Okay, once I got everything I can plug in right away plugged in, Next, I'm going to look at the picture and mark it up. So if you have to draw the picture on a separate sheet of paper, just do that so you can have a visual of what you're talking about. It says given angle 1 is congruent to angle 3. Okay. It wants us to prove that angle 4 is congruent to angle 6. What's nice is they already started putting in the steps for us, so we really don't have to start from scratch. We just have to look at what they gave us. Here it's saying angle 3 is congruent to angle 6. I look at this here, angle 3 and 6 are vertical angles, so those are congruent because of vertical angle theorem. And I'm abbreviating, vertical angle theorem. Next, they gave me a reason of transitive property, so I'm looking at these and seeing what's transitive. Well, if 1 equals 3 and 3 equals 6, then 1 must equal 6. Angle 1 is congruent to angle 6. Next, it says angle 1 is congruent to angle 4. I look at the picture, those are vertical angles again, so those are equal because of vertical angle theorem, the most popular word. And then last but not least, let's see, if 1 is equal to 6 and 1 is equal to 4, those kind of like cancel. That means 4 is equal to 6. That is transitive. And over here, I mentioned that there's actually different styles of proofs. We are focusing on 2-column proofs because it's hard enough as is, and we don't need to like incorporate too much when we're trying to learn proofs. But one of the other styles is a paragraph proof, and the other style is like a flow chart where you have given, and then you have like a step, and it looks like this, and then you have like a reason, and it's the same thing, it's just like in a flow chart format. This is showing us a paragraph proof for this proof. So kind of using the same ideas, we're just going to fill this in. It says it is given that, so you just plug in your given here, angle 1 is congruent to angle 3. We know that angle 3 is congruent to angle 6 since vertical angle theorem. So I'm literally just plugging this in the box. So by the transitive property of congruence, we can say that angle 1 is equal to angle 6, or congruent to angle 6. So angle 1 and angle 4 by the vertical angle theorem therefore we can conclude that angle 4 is congruent to angle 6 by the transitive property. Okay, next proof. First of all, before I do anything, I'm going to plug in what I can. I would put in my given. I put in my proof if it wasn't already there. I write given right here. And now I'm going to look at the statement in relation to the picture. It says Km bisects JKL. Remember bisect? That means like cut in half, exactly. So with Km bisecting, I know that this side of the angle is the same as this. They want me to prove that MKL is half of the entire thing. Okay, first statement right here, it says measure of JKM is equal to MKL. The reason why is because of definition of angle bisector. And then looking at the next statement, they're saying that JKM, this angle, plus MKL, this angle, equals the entire thing. That is angle addition postulate. What is that? I want a dog. What if we had a class pet that was a dog? That'd be cool. Okay, then next, they give us this statement. I look at the picture, MKL plus MKL equals JKL. It doesn't really make sense in terms of the picture, so what they're doing here is substitution. So